Thank you, Sepideh. Thank you for the invitation. I'm very happy to be here and to be joining this great series. So I'll start with a little bit of preamble. There's a lot of stuff that I want to get to, but I think it's important to kind of give a little bit of a taste of what comes next week, even though we're not going to talk about it too much this week, just to kind of give some perspective as to where it's going, because I have a feeling like when we get to the end of the thrust of today's talk, well, we won't have much time to go elsewhere, but I just want to keep it in the back of our minds, this question about evolution and how causality, or our causal inference and our causal kind of way, our causal reasoning, is deeply linked to our evolutionary background. The stories we tell ourselves and each other about how the state of the world changes is intimately linked with how evolutionary pressures will have shaped our cognitive biases. And indeed, it is one of the deepest biases. We must assume that our trust in the inferences which inhabit and animate human consciousness in contemporary humans has evolved and is path dependent. In order to communicate a feature of the environment, in order to communicate the state of the perceived world to another human agent, we are forced to collapse all of that relevant information into a very narrow pathway, a very low bandwidth channel, and this is language. The birth of language, starting with various oral stammerings, developed into the oral traditions of the ancients, and then into the era of writing and reading, the emergence of printing, of the printing press, and now into computerized natural language processing and large language models capable of artificially generating intelligible conversation with human agents. How did this all get started? What happens is that information in the scene needs to get compressed down to a very narrow channel. It is a single line, a one-dimensional representation of a world that is, let's say, four-dimensional. In order to get all that information into a single line, things need to be sequenced according to a very stable code, such that the information can be uncompressed on the other end, in the other brain, on the receiving end. This is where grammar comes in and where syntax appears as methods of bookkeeping. It's a cipher, kind of cipher for keeping track and ordering the snippets of information contained in that one-dimensional representation of the 4D world that is speech or writing, such that this cipher, that using this cipher, we can uncompress it back into a 4D representation at the end of the communication channel. Of course, this compression is lossy, and it is much like a filter. It performs a selection. How these selections evolved in an orchestration between the endogenous chemicals in our brains and the various survival constraints on our early ancestors somehow led them to develop story, narrative, causal accounts of what happened and in what order. They provide a crude codex of our emotional overdetermination of complexes of states of affairs. We can say that causal inference, like narrative, is the result of the shortcuts evolutionary process had to take and are continually forced to take in order to respond to evolutionary pressures. This is why, I would say on a side note, but we should come back to this later, the general intelligence cannot evolve. It can only be invented if it is possible at all. Because as soon as it evolves, it is path dependent. At least that's what I'm claiming. These are issues we'll return to more specifically in the second session, but I want to mention them now to kind of prime the listener with a kind of foreshadowing of what's coming. Keep it in the backs of our minds there. For now, let's focus on a simple idea that our evolutionarily conditioned experience of causality, the classical causality, the billiard ball causality, so-called medium-sized dry goods. The the causality of those things that have evolved, that we've evolved to interact with, solid objects, which we can rotate with our opposed thumbs, those Goldilocks objects, neither too small nor too big, neither too hot nor too cold, neither too fast nor too slow for us to grasp them. Our causal inference also demands three acts, as in Aristotle's account of narrative: a state, a transformation, and another state, right? Okay. So, but here too, evolution is at play. Our genomes and other evolutionary players. We should also mention our genomes and mention the genomes of the various beings that live alongside us, that evolve alongside us, like our microbiomes. And today we could also include our technological environments, all of which participate in what we might call our transcendental evolutionary background. Impose that these lines compose. I should draw it this way to make it clear. Right? These two lines can be composed into this one. Thus so they impose that these segments must be chained together into a single morphism in the language of category theory. Thus the evolutionary background imposes on us certain prohibitions. There cannot be any jumps. We need to establish a continuity, a connection from the past to the future. It is a prohibition of cycles, and all the lines in the graph need to be directed in the same direction, though they may split off and reconnect. The arrows can never fold back on the past. So you have something like this. State 1, state 2, state 3, and they compose. Three acts: a beginning, a middle, and an end, an uptack, a turnstile, and a T, a setup, a challenge, and a resolution, a state of affairs, a transformation, and a new state of affairs. There's an old cybernetic way of thinking about evolution owing to the notion of the self-organizing system, the combination of a selective retention and a blind variation. Ideas coming from Ross Ashby. Evolution is at base a combination of variation and selection, or the line and the circle. The line of variation is a search for new solutions, a mode of sustenance. The selection is a capture and repetition of those lines that end up working, which get rolled up into the evolutionary cycle. Julia Pearl has made this very clear, this guy. He asked, what is the difference between a correlated system and a causal system? In the correlated system, the arrows of influence can crisscross each other and go in all sorts of directions, back and forth. But a causal system imposes that all the lines are directed. So it imposes acyclicality, the elimination of loops. There cannot be loops going back in time. Everything must be moving forward in a directed way, in an acyclical directed graph. In Back to the Future, Marty McFly inadvertently travels to the past, to the time where his parents are teenagers, and risks breaking the rule imposed by both evolution and causation. He's created a loop, a paradox. This paradox is sometimes called the grandfather paradox, after a thought experiment that asks what would happen if one were to travel back to the past and murdered one's grandfather. such that the chain of events leading up to your birth would not have happened, such that you could not have traveled to the past to murder your grandfather, such that the chain would not have such that the chain would not have been disturbed and you wouldn't have killed your grandfather, such that you could have traveled back and murdered your grandfather, and so on. A repeating loop of contradictions that ends up going nowhere. Evolution imposes that these loops be eliminated in our causal inference, and causality, as we have come to know it, causes an equal and opposite reaction. It keeps moving in the direction of the one and only flow of time. In short time loop films, this genre of films that emerged in the last decades, which I call short time loop films, which are similar in some ways to time travel films, only the traveler is not really traveling anywhere. They're more like stuck in a loop. They're going through short time loops, perhaps of just a few hours or so. Within this genre, we have then two different kinds worth noting. There's the materialist kind and the idealist kind. I sometimes call them monistic and dualistic, or materialist and immaterialist, because sometimes this idealism is maybe a kind of a difficult term to use, but let's just say, I think you'll understand what I mean. So in the materialist or monist side, we have Shane Carruth's primer as a prime example, Nacho Vigilando's Time Crimes. And on the immaterialist side, we have films like Groundhog Day and Edge of Tomorrow. You see how different these two kinds of story are. Groundhog Day and Edge of Tomorrow are much like video games, where a player is trying to get past a level. As a player, we constantly fall and get eaten by monsters, but we can just start over and try again until we get it right. The fear is that we may never get it right and that we may be stuck in this loop forever. But in the materialist version of these short time loops, we have a very different situation. Since it is materialist, and since it obeys a kind of monist theory of mind, where your thoughts and conscious experience are tied to the materiality of your brain and your body, every time you go through the loop, you bring that body with you. So in immaterialist or dualist short time loops, it is as though your thoughts and your conscious experience exist on a different plane, and they're not tied to your body or brain, such that somehow you wake up at the beginning of the loop each time in the exact same situation as before, with the same body as before, but with a memory of the end times that you've been through the loop, such that you might learn from your mistakes or get better at defeating the opponent. In the materialist time loops, when you go back through the loop, you end up encountering a copy of yourself that has not yet been through the loop. Since in order to have your memories, you need to take your body with you. You need to take the body that's aged through the loop and take it with you, so ending up with, multiple copies of the same person in the same world. So interestingly, there's this other little known film. It's a made-for-TV movie called 1201, from the same year, from 1993, same year as Groundhog Day. And it's like this, they have this quantum experiment gone wrong, and this guy is like, this guy's noticing that the world is repeating. So the main character, Barry Thomas, informs the quantum time experiments leading scientist, Dr. Mosley, that he is experiencing a temporal repetition. And Dr. Mosley is a monist, oddly enough, like ironically, because this film is not monistic or not materialistic. but he's a scientist, so he has a materialist account of what could happen. And so he denies that it could happen. He says, if the bounce were to happen, everything would loop back to the starting point. Your memory would also be reset along with the universe. The fact that you remember anything about it means that it didn't happen. So basically, he kind of explains it for us. But so in the materialist time loops, you end up with this typical conceit. The characters are forced to kill their doubles, else be killed by their doubles, or there can only be one cycle, one loop, the loop that is the identity morphism. One relation to self. Self cannot be other, and as soon as self is other, it must be eliminated, collapsed back into the one singular self. And this is what I have here. These are just multiple relations to self, and all of them equal the identity morphism. The timeline is in a paradoxical state so long as there is more than one copy of the protagonist, which leads to an often bloody series of events. It is a suicide, the sui prefix in suicide coming from the Proto-Indo-European word for the third person reflexive pronoun suedio. Interestingly, this is even more of a suicide than a suicide normally is, because it is both reflexive and in the third person. It's killing yourself, but in the third person. Yourself is another. I kind of came back to this topic recently because of these news stories about a month ago that just appeared out of nowhere, that were kind of obviously resonated together. In southern Germany, these are gruesome stories, but in southern Germany, there's a woman found her doppelganger on Instagram, and she wanted to kind of escape her life and fake her own death and disappear, and so found someone who looked like her on Instagram and dressed her up in her clothes and killed her and tried to make off with her identity. Didn't work at all, of course. And so this is still now a court case, so she's not convicted of this. The other one is now convicted recently, in New York City, for doing a similar thing of trying to steal someone's identity by, thinking that no one's going to notice if you take their place, steal their documents and kill them, in this case with a poisoned slice of cheesecake. I was, amazed to find out that this actually happens in real life. So how does this killing of your doubles relate to the evolutionary thinking, the evolutionary account we've been looking at? It might be best to first go back to the Future, which gives us a hint. Even though it's not a short time loop film, it's sort of has similar ideas there. It's pointing to some things. Marty goes back in time and lands directly into the lap of his mother, who becomes infatuated with him. It is this predicament that sets off the whole story, because not only does Marty need to get back to 1985, he also needs to make sure that his parents hook up, and so it's like the grandfather paradox, right? So to make sure that he ends up being born. And of course, it's kind of a reflection of a kind of ancient story, the myth of Oedipus, Prince of Thebes, who was destined to kill his father and marry his mother. The tragedy of Oedipus is much like the temporal paradox of the grandfather, a tragic state of affairs, a loop in the generational directionality, the prohibition of incest is precisely the evolutionary counterpart of the imposition of the acyclicality of causal inference. The arrows must not loop back. And interestingly, this is something that Jean-Yves Girard has toyed with. We'll be coming back to Jean-Yves Girard later, but this idea of the Australian Aboriginal nations have this kind of complex kinship structure because they live in very small groups, small villages, small tribes, and need to make sure that it's very kind of incest is something that must be avoided at all costs. It has huge implications. So they have this complex structure of something called skin names, where each member of the tribe not only has a given name, but also a skin name, which marks their place in this generational tree, such that because of their skin name, they can only marry specific other skin names. The idea is that since humans beget babies from onward, it is easy for one's brother to be the age of one's grandparent, and so on. It gets very quickly difficult to keep track of which generation, which branch of the tree one stands on in relation to others. The skin names provide an extra line of defense against incest. They kind of keep the cycles as large as possible so that they're not doing damage. So marrying the wrong skin name is considered incestuous. So in short time loop films, you're forced to kill your double because there can only be one, because there cannot be any loop. Because the presence of a double implies the presence of a loop, which must be eliminated. And this is, so these I'm kind of suggesting these are kind of deeply entrenched evolutionary prohibitions. And they're related to group theory and the theory of symmetries, where a thing is the sum of all of its transformations, all the transformations that leave the thing unchanged. Thus, as we saw with two parallel paths, and we haven't seen that actually, so two parallel paths. This is basically the commutative square. Two paths can lead to the same place, and this idea that we can that a thing is just the sum of all the different ways that we can change the thing and still have the thing. All the arrows that lead from a thing to itself are equivalent to the identity morphism. This includes all the composition paths that end up leading to the same object. This is so the third sense, and perhaps most salient sense that I would like to say, that we kill our doubles. Identity is, so that I first said, it might be confusing because I first said that the causal inference insists that there are no loops, and yet there is a loop. It's the identity morphism. So there's one loop. There can only be one loop. So all the other loops need to be eliminated, right? But there still is that identity morphism. In another sense, which is related, but we should distinguish for now, the act of killing your double is just the act of deduction, of deductive reasoning. It is the logical act of following an implication to its deductive result. In category theory, this is clear. It's the idea, very intuitive, the idea of composition, right? This idea of composition. we've already seen. What does it mean for the arrows F and G to be composable? It just means that there is another line, a virtual line, which we may call G after F, which is the composition of F and G. And this is a simple inference rule. In fact, as we'll see, it's actually the cut rule in linear logic and in the sequent calculus. The two morphisms, F and G, are the premises, and the composite morphism, G after F, is the deductive conclusion. The composite morphism is the logical consequence of the behavior of the individual morphisms, just as the deductive conclusion is the logical consequence of the premises. The composition of two morphisms is a kind of categorical conditional statement. The composition is the consequent and the two composed morphisms the antecedents. Thus, biological evolution will have wanted our arrows to compose, such that our entire idea of logic and what makes sense of what things mean and what it means for something to make sense or not make sense is all filtered through this very basic idea that a bunch of connected arrows can be collapsed into a single arrow. This is the other sense I would like to entertain in terms of killing your doubles. The idea that logical implication and deduction are intimately bound with the idea that all these little stories, these little segments of objects, let's say all of these 3-act segments can all be composed into a single line. That what there is and what is sound, and what makes sense, is what can be deduced from how these arrows are connected, how these arrows compose. So the subtitle I gave to this talk was Ex Nihilo Nihil Fit. What does this mean? It means that you can't get something for nothing, and that conversely, you cannot get nothing from something. The idea comes from the origin of Western philosophy, Parmenides, and Heraclitus as well in his own way, in a roundabout way. Parmenides is a philosopher who said that being begets more being, and that non-being begets nothing. And it's not that non-being comes from non-being or that non-being produces more non-being. Non-being doesn't do anything. Rather, the concept of non-being is absurd. And that's important. Concept of non-being is absurd. He's in a way making the evolutionary imposition of composition explicit. He's saying that if there are arrows, the arrows must compose. In category theory, we can say that an arrow must land on an object. The arrows can't be left dangling, right? You can't have something like this. You need to have an object. You can't just have an arrow dangling. So this just means that a joke needs a punchline. It means that a story needs a third act. The string must not be allowed to fray. Parmenides says that if there were truly such a thing as non-being, then being would be impossible. Nothing could have come from nothing. And on the other hand, it also means that once you have something, as we obviously do, once there is being, there cannot be non-being. You cannot summon the void, as it were. Being can never perish. Being can never transition into non-being. Thus, we are, in a sense, forced to compose. The story can never be allowed to end. And this is kind of the evolutionary thrust, the fact that we're all kind of driven to reproduce and to survive and whatnot. I read this as a very ancient prohibition with evolutionary origins, the prohibition of death. The modus operandi of the living is to avoid death, to keep composing the arrows. This means to keep folding the disparate into the self, the variation into the selection. This is the prohibition of suicide, the prohibition of just letting oneself die, of submitting to gravity and to the forces of chaos that weigh upon us, such that we end the struggle. And like I was saying, so the other idea that category theory lays bare is the notion of commutativity. It's the idea that it doesn't matter whether you multiply 4 times 2 or 2 times 4, you still get the same result. So in a square diagram where the arrows flow from one corner to the opposite corner, it does not matter if you go one way around or the other way around, you still get the same object. You can go this way, or you can go this way. And the two paths are equivalent, though perhaps not equal. And it means that you can take one for the other. This is the deeper sense in which the imposition of acyclicality will have implied that the protagonist must kill their doubles in materialist short time loop films. Killing our doubles is like a dramatization of this process of figuring out that two different things are in fact the same thing, figuring out that sometimes two different things can serve as the same thing, that you can take one thing for another, that one thing can serve the same purpose as another. And this is something I write about in the paper that I had some of you read on something like an operational virtuality. This is the birth of virtuality and of fiction, the as if. It is the birth of hypothetical thinking and counterfactuality. It is what underpins the notion of as if. We can take one thing as if it is something else. And I mean virtual in the sense of Charles Saunders Peirce's dictionary definition, something that is not X, that nevertheless has the same virtue as X, the same effect as X. That's virtuality. And I go on in the article to argue that this is not the same thing as what Bergson describes as virtuality, but let's not go into that here. All of these compositions of arrows take place in what might be called an operational virtual. It is by virtue of the virtual that all these arrows compose. It is because we can see beyond the differences hidden in the objects and look only at the morphisms and discover that one path is equivalent to another and that they both get you where you want to go. So this is, I take a moment to talk about despair. Fantastic film, Fassbinder film, which I looked at, saw again after 20 years. I was surprised to see how little I remembered of it, but yeah, it's a stunning film. And in fact, weakens the point that I wanted to make, because I thought he was taking the place of this other character, because by the end of the film, the protagonist Herman, who's a split personality, he's dissociating from his body, where he watches himself making love to his wife from a distance, and is obviously going insane, and finds this drifter on the street and deludes himself into thinking that this man looks exactly like him, and then starts thinking, oh, well, I could fake my own death and just leave my horrible, he's disillusioned with his life and he wants to leave his life, and he can kind of kill this drifter and dress him up in his clothes and kind of and he thinks no one will ever know that it wasn't, that it wasn't him who died. But obviously there's no resemblance between these two people. So interestingly, it says something else. The time loop films say more about this collapsing of morphisms to of loops, of cycles, collapsing them to the identity morphism. This one says more something about virtuality and about the dissociation from physicality that happens in this moment of this birth of the virtual, let's say, this capacity to abstract from what's before us. So indeed, the extreme similarities between the structures of language and the structures of physics and causality are owed to nothing esoteric. The similarities have only to do with the fact that in each case, we're trying to fold everything into a single line. We need to compose all the parallel paths into a single path, which is why we have rules of grammar and why we have rules of composition, so that everything folds up neatly and we can track multiple dimensions within one dimension. We can compress everything down onto one line. And remember, Heraclitus said something very similar to Parmenides: you cannot step in the same river twice. Not that being is immutable, but that everything is forever changing. Nothing remains the same. This would seem to be the opposite doctrine, but in fact is exactly the same. As Quentin Meillassoux said somewhere, Heraclitus is a terrible fixist, because if change is everywhere, change is nowhere, right? There is no change if there is not enough stability for change to take hold and express a difference between the before and the after. So in a sense, we have the same prohibition. And I think the first philosophers were, in fact, kind of making explicit what these evolutionary prohibitions were, right? That was the first kind of philosophical act, to kind of somehow make explicit these prohibitions that were already there. They weren't inventing anything. They were kind of just writing it down, or not even writing it down, but kind of expressing it. It's the same idea that's repeated in all of those grand philosophical arguments for why there is something rather than nothing. Like Leibniz said, God was forced to create the world and he could not have decided otherwise, because there is some kind of law greater than God, previous to God, that is compossibility, the empirical evidence before us. That somehow the very empirical world before us is retroactively causing or quasi-causing the world to have been the way it is. Quasi-causing, using that Deleuzian term, quasi-causing God to have created the world and set everything in motion such that this state of affairs have eventually become the case. This is the same idea in the so-called anthropic principle, or the question of the fine-tuning of nature. The idea that if things had turned out just slightly differently, if the laws of nature had been ever so slightly different, the energy in the universe would not have clumped together into matter, and there would have not been a world to speak of. It seems clear, as Brandon Carter, the astrophysicist, is famous for pointing out at a conference on Copernicus to boot, that the very fact that we're here observing the universe implies that certain restrictions on what we might expect to find, implies certain restrictions on what we might expect to find when looking out into the cosmos. The universe cannot be younger or older than a certain age, a certain range, that allow for the atoms in our body to hold together. The temperature can't be too high or too low. Thus, it seems that our empirical experience is somehow influencing, looping back to the beginning, and quasi-causing the world to have been thus. So these ideas, and we get into some somewhat technical stuff here. These ideas intersect the transformation that was shared by the fields of mathematics and logic and computation. Well, not yet computation, but the computation is an offshoot of it in the late 19th century and early 20th century. At the beginning of the 20th century, there had been success in putting mathematics on firm foundations. We were interested at the time in making sure that when we calculate, we were not losing track of the underlying logic. The semantics of what we mean when we say this is true, this is false, needed to somehow carry forth through these huge mathematical constructions that we were now dealing with, right? We wanted to make sure that the meaning was maintained through all those various calculations. So indeed, we needed to make sure that mathematics could be reduced to the world we knew by acquaintance. That was Russell's term for it. The world is basically, that world was basically the world of set theory, which formalized our intuitions about ensembles of objects, objects and containers, objects being put together in various ways and ordered in different ways, about how objects can be taken together or apart, or how we could combine them, how we can compare one set of objects to another set of things. All of the while keeping track of everything. That was important. So at first, this was quite successful with work in the axiomatization of math by people like Peano and Dedekind, Hilbert and Frege. There was a loose idea known as logicism, that mathematics should be completely deducible from logical principles. And set theory was known as an extension of logic. So it seemed clear that we should try to place everything within the segmented spaces of set theory. Not everything was going so smoothly. So these are some of the people involved here. Not everything was going so smoothly because there were some disputes in mathematics about how this should be going down. There were those who made liberal use of the notions of these kind of modern 19th century kind of conceptual tools and mathematical tools that were coming out like infinities and ideals and cardinalities and arbitrary functions and all these kinds of things that were being used by people like Riemann and Dedekind and Hilbert. And then you had this group who were opposed to these approaches, like Weierstrass and Kronecker, quite notably, especially Kronecker. These latter were worried that we were losing track of what it meant to calculate. We must be able to recover a value through calculation, not merely prove that it exists through some conceptual trickery using ideals and infinities and arbitrary functions. Nevertheless, the logicist ideas were experiencing success into the early 20th century, with Riemann's ideas finding applications in analysis and in physics, finding important supporters in Minkowski and Klein. And for a time, it seemed that we were putting all these calculations on firm footing, basically set theory, which the idea was we could all intuitively grasp. But then the problems started piling up, paradoxes. Some of them seemed like minor amusements, but soon they started becoming a real problem. Cantor himself had discovered contradictions in the way ordinals and cardinals were defined. And then Russell's paradox brought this to the fore, where it was obvious that something about set theory was off. It was too easy to define a set that seemed useful and rigorously defined and find it to be self-contradictory. In Russell, this takes the form of the set of all sets that do not contain themselves. Does this set contain itself or not? If it does, then it does not. And if it does, if it does not, then it does. So we're in this paradoxical state. For this guy, Poincaré, these problems were the result of what he called impredicativity, the idea that we just assumed that a set contained a certain element. We treated an element as if it existed simply by stipulating, by claiming that there existed such an element inside a larger whole. He insisted on a predicative approach where we have an explicit construction of the intuited element. And actually, Russell went on to, in his set theory, exploited this idea. It's a modified, in his type theory, sorry, not his set theory. It's a modified form of set theory where instead of being freely capable of mixing and matching sets, you're restricted to working with sets on a per type basis. In the Principia Mathematica, written in collaboration with Alfred North Whitehead, they produced this first kind of thorough attempt at type theory, which later would have a lot of success in computing. In parallel to this, you had Zermelo, who thought that Poincaré's insistence on the predicative went too far, and that there were plenty of impredicative approaches that worked without issue. He thought rather that we needed to clarify the logical axioms founding mathematics and just be more precise in our axiomatics. This project developed over many years and eventually gave us ZFC, Zermelo-Fraenkel with axiom of choice, which captured all of the mathematics of the time. It's extremely powerful, but it's basically an axiomatically restricted use of set theory. But it's a little bit, let's say, it's a little bit ad hoc, you know. It's like it's put together in a way that just works, but it doesn't seem well-founded or kind of canonical in any way. So meanwhile, you had Brouwer, this guy, who was developing a completely different approach, somewhat closer to the old kind of pre-modern kind of tip of the hat to Kronecker and also to Poincaré, which had leaned into the intuitionistic, but Brouwer took it like all the way into this extreme intuitionism. And in particular, he regarded the liberal use of the law of excluded middle as absolutely uncalled for. So this is the idea that that P or not P, that everything is either true or false, or that P equals not P. You know, that you can prove by contradiction, basically. So rather, for him, a constructive perspective meant that P or Q, you know, you could only say, that's what you could say. You couldn't say P or not P. You had to construct something in the end. In other words, since we could not assume that either proposition is true or false, we could also not reason by contradiction. We could not prove something by reductio ad absurdum or by demonstrating that a proposition must be true by showing the absurdity of it not being true. Brouwer went on to develop this parallel foundation of mathematics based on these ideas, which was shown to be surprisingly, equivalent to the ZFC axioms, meaning that you could do the same mathematics with or without this law of excluded middle. And so that there were these two systems grounded in very different kind of philosophies ended up being equivalent to each other, which was seen as a kind of vindication of the formalist approach and the modern theories. But then, so then you had Gödel, and so he really broke everything. Kurt Gödel showed in 1931 with his infamous incompleteness theorems that logicism and formalism were fatally flawed. And these two theorems showed through an ingenious method called Gödel numbering that you could encode mathematics into a meta-mathematical numbering scheme. He was able to show that all and any axiomatic systems are incomplete. For instance, Peano-Dedekind arithmetic or ZFC set theory necessarily allow propositions P that can be coherently formulated such that neither P nor not P is provable within the system. This was the first version of the incompleteness theorem, which shared some resemblance with a previously known paradox called Richard's paradox. The second incompleteness theorem says that it is impossible to show that the consistency of an axiomatic system by a proof that can be formalized within that system. So you can build a sentence that proves the consistency of a system from within the system, but it turns out not to be provable. Or you can appeal to another overarching system to prove the consistency of that system, but that overarching system will also be incomplete, right? Thus, if a system is consistent, there is no finitary proof of it. And if there is a proof, then the system is inconsistent. So this was all very difficult to accept by these guys. Just as math seemed to have emerged from its battle with paradoxes, with a wounded and clumsy form of set theory, severely restricted, amputated, if you will, much like the soldiers returning from the Great War. Now it seemed that all of this formalism had turned out to be somehow wrong-headed. This was the end of this logicist era in mathematics, an era in math where we thought we could prove that our intuitive experience of the world implied a clear semantics, or that we needed to reduce everything to a kind of semantics that we could all kind of relate to and agree on in a kind of intuitive sense, in a kind of a knowledge by acquaintance that we just know because it's so simple and self-evident that if we can reduce it down to that level, then everything else will make sense and we can know that everything's on firm footings. So the idea that if mathematics complied with this basic logic that we all implicitly know to be the case, we could just know that when we calculate and when we churn through these large numbers, that everything is going to make sense. That the semantics of our human existence somehow follows through into the higher orders. And this, of course, would combine with Turing's result. Who soon after showed in another way to think about Gödel's incompleteness, a kind of mechanical interpretation which responded to Hilbert's Entscheidungsproblem, the decision problem, that showed that certain programs would make a computing system go on calculating forever without coming to a halt. It showed that you couldn't know before actually performing the computation whether a certain program would halt or not. There's no way to circumvent the process of actually performing the calculation. You cannot know in advance without an appeal to some hypothetical oracle or to some overarching system that would just tell you as if from the future what the future holds, such that we could avoid going down the wrong paths. But this doesn't happen, you know. In reality, It just doesn't happen. And notice how a lot of this, again, concerns the notion of circularity and acyclicality, the prohibition of circularity, the imposition of acyclicality. It goes back to early philosophy, right? Recall Plato's dialogues. Socrates is the one who traps you in your own contradictions, in the contradictions of your discourse, who makes you discover that your arguments are circular and that they go nowhere. Descartes, too, insisted that logical argumentation needed to move from argument to argument and eliminate gaps. You know, as we were trying to figure out how argumentation worked, we needed to form a continuity without gaps and without circles. That was what allowed us to move on, eliminate the circles and eliminate the cuts. In any case, after Turing, in parallel to the work of Church and Klein, do I have photos of that? No. Who developed lambda calculus and eventually the type lambda calculus that was meant to avoid such paradoxical situations by typing the system, just as Russell had done with the paradoxes. You can just define the paradoxical or incomputable functions as a specific type, the absurd type or the bottom type or the empty type. Basically, it's the type that has no arrows going to it. You know, it's like the bottom type. It's the type from which arrows can come out, but arrows, nothing goes to it. Nothing constructs it. Nothing constructs the absurd. The absurd produces, but never constructs. And that's what we'll be looking at next week. So by kind of taming the paradox, by making it of a certain type, and by typing the system, keeping track of those types, we could go on freely calculating within the remaining domains of those calculable functions, what we now call, functional programming. With the advent of computing, all of these mathematical, logical questions about axioms and formalism and proof were given a substance, an actual machine, Leibniz's ratiocinator. Only once again in a crippled form, the computer seemed amputated, for unlike the ratiocinator, it could not give a true or false answer for all propositions. Some propositions, as was Brouwer's intuition, are neither true nor false. And we already said that the basic rule of composition can be interpreted as a deduction. Well, that was what Gentzen was doing in the 1930s, was developing kind of also in the aftermath of Gödel, and this was the kind of birth of proof theory, to study proofs themselves as logical objects or mathematical objects in their own right. And developing a way to look at inference rules such that the proposition and the proof is always held tightly together. You keep them together at all times so that you can follow the process of the proving at all times. In Hilbert, you had several axioms and one inference rule, modus ponens. Whereas in Gentzen, you had just a few axioms and many inference rules, like several ways of inferring. And this was basically the birth of proof theory. And so the composition rule we looked at before, if the kind of triangle diagram, if there's an arrow from X to y and an arrow from y to z, then there's necessarily an arrow from x to z. So you just have to suppose that these objects, x, y, and z, are propositions. And then the simple diagram presents us a rule of inference. It is actually what is called a preorder. If you add to it these identity morphisms in category theory, you end up with this relation called less than or equal to, or basically the preorder, this idea of less than or equal to. It's just the idea that x is less than or equal to y, and y is less than or equal to z, and x, therefore, is less than or equal to z as well. And they're all less than or equal to themselves, right? Because of we include the equal sign. It's less than or equal to. It's a diagram that presents to us the intuition of something coming before and something coming after, or something meeting, they call it meet as well, or going up to something, or starting from something. It's also very closely, it's basically the idea of a limit as well. That's how you define a limit with similar concepts. You define kind of the shallowest cone over something in order to define the closest, like, such that all of the other contenders are equivalent to this one that you were talking about. And that's how we define the limit. So the diagram presents us with the intuition of something coming before. Yeah, like I said that. These two functions in conjunction give us the chain that is the preorder. We have something here that, again, that resembles the old cybernetic ways of thinking about evolution. You have a repetition and a variation. You have a circularity and the self-relation with the confrontation to the outside and an inclusion of the other. And if we enrich this idea just a bit, we end up, with we can end up with something like this. Which is called a partial order, which gives us a kind of basic idea of equivalence or equality, where all these things are equal to each other. We can number them, numbers 0, 1, 2, 3. And if we enrich the idea just a little bit more, we gain something called the category C, which we add the notion of the Cartesian product, which is well, let's just call it. I'll just make it a small x. And then this idea that there's one number that's best at picking out these pairs. And the Cartesian product is just how you pair things together. Pair two sets together in pairwise, in a kind of one-to-one correspondence, like a truth table or a multiplication table. So it turns out that this is equivalent to left-hand weakening in Gentzen. These inference rules in classical logic and propositional logic. Left-hand weakening, meaning that basically it just means that if you have if P implies Q, and then if you're given P and A, then you still can get Q. It still implies Q. You can add this arbitrary element to the left side of this symbol, the turnstile symbol, this symbol. To be clear, this symbol, turnstile symbol between the proposition and the proof. And so this is the abstract notion of product that we just saw, Cartesian product. The abstract notion of a conjunction, the inference rule for a conjunction. While if you weaken in the other direction, the right-hand weakening, you get the coproduct, which is otherwise known as disjunction. So on one side, and this is very important, the turnstile in the sequent calculus on the left side is always conjunctive, and on the right side is always disjunctive. So I'm gonna draw that. Just like you have this turnstile, and then on this side you always have and on this side you always have or some idea of andness and orness. So yeah, if you go in the other direction, you get the coproduct, which kind of means that so since it's an or, it means that if you're given P, so you know P gives Q, and you're given P, which means that if you had P or Q, Q or A, then it would also, that implication would still hold. The P also gives Q or A. So you can say or A on the right side, and you can say and A on the left side. I don't know if that's making any sense. Maybe to David Gauthier, who's here, he probably gets what I'm talking about. But anyway, I don't know if I'm making this clear to everyone, but we'll see. We can talk it out a bit later. I'm coming to an end here. In fact, this is a very interesting feature of the sequent calculus. The logic of the product, the logic of and is on the left side. And so let's stay close to Gentzen here. Logic of and is on the left side, and the logic of or is on the right side, the side of the result or the side of the proof. This mirror image of the sequent calculus broke down with logic other than propositional logic and didn't work with predicate logic and so forth. However, it is Jean-Yves Girard, this guy, who figured out how to restore that mirror image elegance for higher logic. And the way he did that is really interesting. It's done. Okay, so one thing I forgot to say is that, so again, in Gentzen, you have all of these left weakening, right weakening, left contraction, right contraction, which are similar, but kind of the opposite, mirror images. And then you have the cut rule. And what he famously proved was that the cut rule is it's basically like this composable triangle here, this triangle where you can just cut out these two. You can cut out these two and just take this, and because it's equivalent. The cut rule looks like this, but basically that's all it is. It's just cutting out this part that's common to both sides, and you're left with this. And so what he showed is that you could eliminate the cut you could approach logic with the cut rule, but he proved, and in fact, I think it served the purpose of proving the consistency of Peano arithmetic. You could prove that that you could always have it. You could always, whenever you can do it with a cut rule, you can do it without the cut rule. You can do it with these other rules, right? So that was a very significant. That was probably the most significant thing that he came up with. And then so then you have Girard, who comes in like in the late 70s, 80s, and he's so he figured out how to restore this for kind of more general logics. So it was done by dropping these other forms of contraction and weakening. So he disallows this in his new logic. This logic that he develops called linear logic, in which he so it's important to underscore the motivation for Girard, and it's something he's still alive, and he's a very, very interesting speaker, very interesting thinker, and thinks very metaphorically, and he's quite the brain and the character, a little bit of a troll and a bit all over the place. But Girard's account of mathematics is that this whole kind of formalist program and axiomatic approach leading up to Gödel, what he calls like the 19th century logic and mathematics, is that it was based on this idea that you could have your cake and eat it too. As he puts it, that you could put everything on the table, including the table, right? And he says, so then you had the success of the intuitionistic or constructivist program. I'm talking now, I didn't mention them, but these guys, Brouwer, Heiting, and Kolmogorov are known for this kind of my pen's not BHK interpretation, which ends up being, you know, the kind of interpretation, the kind of leading logical interpretation for this type theory approach to computing, which gives, and computing was giving a real substance to this logic at the time, and BHK turns out to be on top, you know. And for a long time, you know, it was thought that is this whole thing in mathematics, for like in the post-Second World War era, you had the Bourbaki French mathematicians that kind of come together and put all the math back to get, like, try to figure out where the kind of state of the art was. And they were really pushing this, the axiomatic approach. And the kind of new approach was this computing based machining or whatever. It was like it was kind of frowned upon, not frowned upon, but kind of dismissed as a kind of lower form of mathematics because it was applied, because it was technical, and because it had to do with like programming these machines and making them function. And whereas you had this idea that, oh, the real math is happening, you know, in the math department, and it's all axiomatic and it's all very kind of logical, but this kind of BHK kind of constructivist approach was like a lesser form. It was like, but it was turning out on top. And mathematics, anyway, we don't have to go into the category theory stuff, but anyway, so that was a short parenthesis. So Girard is kind of going in this direction as well, but even more. He's saying that all of those problems that we encountered, all the paradoxes and the incomputability and so on, all stem from the idea that we think that we can conjure up operators at will and apply them to the system at hand. We have a bunch of numbers and we can multiply them together and we can add them together, but this multiplication and this addition itself doesn't get used up, right? The numbers get crunched up, but the operators stay pure and they never get used up. There's somehow this infinite resource that we can just pull out of our minds and just apply them at will, and they're always there when we need them. So it's like, as Girard says, it's like an infinite ocean from which we can take infinite spoonfuls of our operators and apply them at will, and the ocean is always still there. So this is sort of the difference between, this is kind of the reason why I was pointing to this distinction between the materialist short time loop films and the immaterialist short time loop films. In films like Edge of Tomorrow, the video game style film where you're just repeating and until you get it right, you can learn from your mistakes and you get it right. But it's like you can apply as many times as you want your operators. You can have your cake and eat it too. That's what it means to be immaterialist, really. That's what it means to be idealist. It's not resource sensitive. Whereas the materialist short time loop films perform this resource sensitive dramatization of what's going on, where you can't just start over from the beginning. You're given you're kind of thrown into the situation with a certain amount of tools at your disposal, and once you use them, they wear out. They're part of causality. They're part of the material world. You can't just start over from the beginning with those tools again and have new knowledge. So I hope that kind of makes it a little bit clearer why I'm talking about all this stuff. Linear logic begins by introducing these new logical connectives, which behave sort of like the regular ones. You have this tensoring operator that behaves kind of like the AND operator, and you have this what do you call this? I don't even know what it's called, but it's basically it's a connective, meaning it's kind of like implication. It serves the same purpose. It works similarly. And then instead of having the terminal object or truth, you have this logical constant I. But otherwise, it kind of works the same way. The only thing is it doesn't allow you to do all of these things. It doesn't allow you to do weakening and contraction. And so it turns out that because of this, you lose the capacity to contract or weaken your propositions at will. You cannot reason that X implies Y, then if X arrives with an A attached, you can still get Y. You might not. And if you lose the capacity to reason that X implies Y, then you can be sure that X also implies Y or A. You can't assume that anymore. So what he got out of this is called multiplicative linear logic. If you look at only this section here. And it turns out that it is equivalent to closed symmetric monoidal categories. And that's important because they turn out to be equivalent to quantum physics. They are the logic of quantum physics. He had defined the inference rules of quantum physics, where the intuitionist propositional logic had been equivalent to Cartesian closed categories. The category of sets had to do with objects and how they interact, how we can take them all together. And they have this notion of the Cartesian product, where you can line things up this way and and then get the diagonal. Well, this is not possible anymore, specifically because this is not possible anymore, because these weakening and contraction rules are not possible anymore. You can't line things up that way. You can't line things up on in a one-to-one correspondence and get this Cartesian product. You have this more abstract way of thinking about a product, which is a tensor product, which turns out to be how we talk about quantum systems. So it's found that this new linear logic in the 80s was in fact the logic of quantum mechanics. And the fact that you don't have a Cartesian product reflects the notion that in quantum mechanics, having two things together is not equivalent to having them apart. So when we're dealing with sets, we can just take one set and line it up with another, adding a dimension and say, this is the Cartesian product. You have a one-to-one correspondence between the elements. But in quantum mechanics, when you have two things together, you cannot necessarily separate them or without affecting them, without changing them. And that's called entanglement, right? Two quantum objects together does not fit the description of what we had hitherto thought of as a product or a union. In fact, the way to think about them is rather through the idea of a tensor product, which is precisely what the symmetric closed monoidal category gives a kind of rigorous conception of. So what I'll end with is that this, interestingly enough, gives us the, let's see, the no-go theorems. Linear logic recovers this idea of that it's because in linear logic, you can't weaken. You don't have this sense of weakening in the theory, which is why in quantum physics, the cloning is not possible. The no cloning theory, the no cloning theorem you may have heard of. It's because of this. It's not possible to infer these things. You can't infer the weakening rule. You can't, and so also the contraction, the fact that you can't, as in the sequent calculus, just infer that if you have two of the same object, you can contract them into the same. That's also not possible because you don't have this Cartesian product. You can't diagonalize. And so deleting is also not possible in quantum physics. You can't delete and you can't clone arbitrary quantum systems. So I was hoping this would be like a kind of aha moment for everyone. I don't know. It's pretty technical, but for me, it's kind of like this amazing thing that logic and computation and the avoidance of paradox turned out to, in their trying to figure things out in a way that made sense in terms of resources and resource management, in a kind of materialist manner, turned out to be exactly the shape, if you will, of quantum physics. So that's the end of my talk for this week. Next week, I would like to go into some speculative reasons for why this might be. So today we talked about ex nihilo nihil fit, right? Which is what linear logic is. It's saying you can't get something for nothing, right? Resources are sensitive. Next week we'll be talking about this, from false premises, anything follows. From the absurd, everything is created, but the absurd itself cannot be constructed. Okay, thank you for listening, and let's have some questions.
Yes, thank you, Sepideh. And thank you very much, Alexander. I didn't expect it. Your talk was very complete and amazing, and you put very many points and discussion here, aspects nowadays about the causality and relationality in the ways of we knowing. There is a discussion nowadays, especially with the ChatGPT 3, 4, and all these new tools, no? In the sense of how do we know, and in which aspect we know, and in the sense of we know, we generate relations with the others and relations with the milieu and all aspects of relations. So in that sense, Alexander, I want to ask you, following your diagrams, in which sense do you see the aspects of diversity and cohesion? These two variables in nowadays, that is
Diversity and
cohesion and diversity.
Cohesion,
yes.
Cohesion.
Yes, cohesion. Yeah, sorry, my back English, cohesion. Yeah. That for me, two variables that nowadays is in, I don't know, it's almost extincted for me, because in the aspect of diversity is in the sense of technology, as you know, and you putting very clear that no diversity and biodiversity, etc., and Stigler too, you know very well that, and cohesion in the sense of no homogeneity, because it's not the same cohesion that homogeneity. No, it's not the same aspect as you understand, as in a society, or as a aspects of metastabilities, but the metastabilities in diversity and cohesion. How do you see in this aspect in the diagrams you put very clear here in your presentation? You may be seeing these two variables as a whole system that we live, no? In biodiversity, no diversity, and techno-diversity too. Why not? So this is my question for you, Alexander, and thank you very much again.
Thanks for the question, Renzo. So yeah, I mean, I think maybe diversity is something we should talk about more next week, because we'll also be talking, like the way I framed it anyway was the multiverse and all that, but it has this idea built in of like all of the possibilities in parallel. But certainly, yeah, so cohesion, it seems to me that, well, so you framed it in terms of ChatGPT and all that, and it's a big, there's so much in that to unpack, and it's so interesting, but also kind of dangerous and problematic, and we're all kind of, we're in a world that's rapidly changing. And the question of diversity is super important, because the models, of course, the models, yeah, the models are biased, and they're only as good as the how they're trained and the information they're trained on. And we know that it's clear that they're not diverse, but or they're not it's very hard to reach that kind of that point where they can reason and although I think it's not so bad, though. It's not as bad as we could have thought. With the old one, a few years ago, the Microsoft one that just went on Twitter and started becoming this racist bigot very quickly. Just quickly became a racist bigot. GPT-3 has been much better than that. Like it's going in a good direction. Apparently GPT-4 is even better. So let's hope that trend continues and that it, but in terms of, so it's something I kind of, something that related to what I was talking about, especially at the beginning, is this evolutionary aspect of reasoning, how our causal reasoning is so influenced by our evolutionary background that you know, Noam Chomsky recently was critiquing the large language models and saying like, you know, they can't reason causally. Like they say they still can't reason causally, so they're stupid machines. Like we can reason causally. It's very easy for us to, when we see the apple fall, to say, that was gravity, or that was relative acceleration, or whatever. We can have some kind of causal account. But what I'm trying to say is that that's kind of part of the problem. That's what's holding us back in a way, you know. There's always seeing things in that way is precisely what I think we should be trying to see beyond, because this is how evolution programmed us to see things. But now we're faced with this science that tells us that actually stuff doesn't work that way. The world is not that way. And we're still stuck with all of these mechanisms and saying that we're still patting ourselves on the back, thinking, you know, we can think causally, but actually we shouldn't, maybe we shouldn't be, you know, and I don't know exactly what that looks like. But it's certainly, I think that it's kind of wrong-headed to be kind of just self-congratulating ourselves about, you know, thinking causally and reasoning causally, because because, you know, if you think causally, then if we're an artificial intelligence, we've been trained on medium-sized objects that we can hold in our hands and all this, but that's a very narrow way of looking at things. So you know, the goal should be not to just limit ourselves to that, but maybe you know, the right way to think about it is to think about these artificial tools as ways of helping us achieve that, to kind of and I think of this whole project in terms of an alignment between, for lack of better terms, because these terms have been so co-opted in the last decade, but enlightenment and ecology. And enlightenment, enlightenment, like a kind of Promethean ecology, if you will. And ecology is no longer you can't even use that. The term is so loaded now, but it's still, you kind of get what I mean. It's this kind of alignment between the idea that if you want to be diverse, if you want to take into account other points of view, other ways of existing in the world, it kind of goes together with stepping out of your own biases, stepping out of your own kind of narrow-mindedness. So they kind of go together, and the two things are aligned to begin with. So they're not opposed to each other. This whole kind of, in the recent decade, like there's this divide between ecology and the rationalists on the other side. But I think, no, they're kind of the same thing. And we need to see in what ways they're actually the same thing.
Yes. Just for close, Alexander, thank you very much, because I remind Martin gave us a few weeks ago a workshop about improvisation. For me, Chat GPT 3 or 4 is a good improviser in that sense. They improvise but in relational improvisation, because they give us relational improvisation in the aspect that you showed us in the graphics, no? But but in the same aspect, give us the question: is this work for us? How much if this relational improvisation exists in us as human beings, taking in the sense of the Stiglerian aspect of mnemotechnique, sterilization aspects, and protections, etc. How we can collaborate with this improviser that is more fast than us in this improvisation, in this relational improvisation, no? This is what you mean too. So I think the aspect of noetics, noesis, is quite of the individual, the Simondonian aspect of the individual, something that we are not much clear here nowadays what that means in this sense, in this causality as a human. No? At least for me, it's not. But listening Martin a few weeks ago about improvisations with instruments and music, and now thinking the improvisation with the ChatGPT and with your graphics, made me think about that. So both relations in this. What is the very subtle wall between both process? I don't know what I mean. This is something like that. Thank you very much, Alexander. It was good.
Thanks. I see Martin and David have their hands up. Whoever, Martin, I guess, is first. He's on top in my thing. So, yeah.
Great talk, Alexander. It's great to watch you think for the first time. It was really a delight. Three things. First thing is that your doppelganger right behind you, and can we all agree to just get along?
I hope I don't have to murder him. But yeah, I thought it was April Fool's, so it was a good chance to do something like that at the back.
Yeah, I really appreciate what Renzo just said, because I was going to see if I can finesse a discussion from subject positions to subject formation. And you know, I've been working with jazz as a thought experiment for a lot of these issues, and was really happy to see the way that you mapped the distinction between causal and correlative logics.
Mm.
And it seems to me that jazz seems when it's experienced and viewed after the fact as music notation, it seems causal. But the process of creation, and I want to mention from composition to improvisation, seems much more clearly correlative. For example, the process of composition at that really important moment in the history of jazz, where it evolved incredibly fast, with an emphasis on the word evolve in your context. We had Charlie Parker improvising over a song called How High the Moon, night after night after night. After having prepared in the practice room any number of pathways through the song form, right? And then this guy, Dean Benedetti, would follow him around and tape record all the different improvisations, actualizing spontaneously both what he was bringing to the bandstand and what would happen interacting with the other musicians, which gets to my second point. My third point, having to do with intentionality in this context. Okay, so the correlative aspect is that Dean Benedetti would tape record, right? And then he would pass out these tape recordings to people throughout the jazz community, and they would transcribe the solos and pass those around, and people would practice them, and also people would use those as materials for improvisation and also composition, so that someone, could be Benny Harris, could have been somebody else, came up with the tune Ornithology, which Charlie Parker claimed ownership with because it was his improvisations that generated this distributed behavior over time, correlated through the community and then back to the original source. So we have that kind of correlative behavior. And then we have the correlative behavior that complicates the notion of intentionality, because while the jazz musician may want to superimpose upon the moment what he'd been practicing on the band in the practice room, the interaction which takes place at a different speed of cognition, because there are actually three forms of time cognition coexisting simultaneously. And I think you know a little bit about, you've read, I think, a little bit of what I'm talking about here. There is also a correlative aspect of the generation, and now we're moving from subject position to subject formation, and the idea of thought instead of subjectivity, and wondering whether there's a distinction there that you might want to make, but it also suggests that it is both correlative and distributed form of cognitive behavior, which is completely contingent from one moment to the next, given what I refer to as the phase space of creative evolution in the form of both improvisation and composition. So maybe I should just stop there, because I think you know where I was going with the third question.
Yeah. Yeah. Well, I mean, I think, yeah, I do. I think I know where you're going. And something I've thought about a lot. But this question about whether that kind of contingency and that kind of spontaneity and creativity is somehow low level, so that, like, because it seems to me nowadays anyway, that the whole kind of thermodynamic way of thinking about things, this kind of, far from equilibrium thermodynamics and Prigogine, and this idea that there's, like, that those guys were trying to say at a certain time that this chaotic creative aspect was somehow lower level than the deterministic aspect, and that's what I'm not sure about anymore. Of course, that it does, like, it doesn't mean, see, I don't want to espouse a kind of block universe completely deterministic idea either, but yeah, I think there's just kind of more to that story, especially given quantum physics and the kind of just weirdness about it that just says, like, when I said, I don't know if I still have my, can you still see my drawing pad here? I don't know if it's still shared, but that whole thermodynamic aspect is what I was referring to as the or, and in Deleuze, there's this whole thing in logic of sense, and I think also in difference and repetition, and maybe Anti-Oedipus comes out, this kind of idea of and to or, and in Aesthesis and Perceptronium, I'm talking about how, in the fourth chapter, how this corresponds to what quantum physicists called decoherence.
There's still,
in quantum mechanics, you have this where things exist in superposition, and then in the thermodynamic account, or in the macroscopic account, let's say, you have this where one thing is in one place or another, or at one time or another. Whereas in quantum mechanics, it seems that things can be spread out, in different places, and in, like, potential being spread out in over space and time, and even things moving back in time, as in the Feynman diagrams and all that, the kind of antiparticles are positive particles, but traveling
Backwards in time. Yeah, I was using that diagram for to describe and in fact, I've made the argument that gravity's rainbow is actually constructed based on one of those Feynman diagrams, and there are interesting kind of biographical kinds of connections between the two of them. But there are people that are still trying to reconcile this, and Prigogine actually had a center for nonlinear dynamics at Austin, and he had 6 centers around the world, and they're all working on different problems. And I think people are still trying to reconcile his work with quantum mechanics, and you know, in other words, that work is still going on. And there's one person whose name I can't remember right now has been getting a lot of splash lately, and but that's neither here nor there, and I can appreciate that things look different when you change the scale. When you change, but here's the question that I raised earlier. What does intuitionist mathematics do to this? So what I wrote in the chat was, well, how about Kronecker, Poincaré, Brouwer, and even Spencer Brown and the role of the continuum? What if we embrace the coexistence of doubles? That's why I was suggesting that maybe we could all get along. That was like the point of my initial joke. With doubles with respect to virtual futures for a body, for a system, or for thoughts generated by bodies, systems, and so forth. So do you push yourself a little bit further in that direction with respect to what intuitionist mathematics has to offer?
I think not. I mean, I think now, I think Jean-Yves Girard has convinced me that it's kind of like not enough to think that. It's kind of still, it's better, you know, the BHK or the, you know, intuitionistic or constructivist approach is better. Of course, you know, you want things to work. You want your computer not to halt. You want you know, to produce a result. You want to, you know, you want things to work, to function. So obviously, if you stick to BHK, you're in that territory. And you're not just kind of fabulous, you know, just inventing things that can't be done, you know. But he just takes it to a even further in that direction, I'd say. He says, no, there's like even our operators are limited resources, and so we can't even. So it's kind of, I would say it's in the same direction. I don't know about continuity and all that, but I don't know. I mean, as the more I get into this, the less I think I understand. You know, I have all these moments where I'm like, this is really amazing, but also these kinds of like you feel like the ground slipping away beneath your feet because it's just so it's not very secure at all. However, there's very interesting things in quantum physics and category theory, how category theory and the categorical approach to physics kinds of, it starts to give us in almost like intuitive ways of grasping how say like relativity is similar to quantum mechanics. Like what is similar? Like categorically speaking, there are a lot of similarities. For example, this thing I talked about at the end there, where there's no Cartesian product there actually isn't a Cartesian product also in general relativity. Having to do with like topological spaces. You know this stuff about topological space, topology. Like it's basically about keeping track of how many holes the space has, and so the typical idea of a donut being equivalent to a coffee cup or something, a coffee mug. It's for the same reason that you can't kind of topologically stretch a donut into a sphere, that it's for this kind of same categorical reasons that you can't clone in quantum physics. The same kind of inference rules apply in the category in the category they're using. I think it's cobordism kind of way of looking at topological spaces, relativistic topological spaces in general relativity, and how they're looking at quantum mechanics. There's structural similarities in what you can do and what you can't do that are kind of just made intuitively obvious by approaching things categorically, which is very interesting, because that's also why I was talking about earlier that I started talking about this line, and this one line that everything gets crunched up into when we discuss things in speech or in writing. And also that was part of the problem with formalism, right? You're trying to contract, like if you can't make one equation, then you still don't understand it, right? And diagrams don't cut it. Like if you can't state it in one formal equation, then you still haven't understood what we're talking about, right? This was the kind of logicist idea, but it turns out that when you're doing diagrams, you also are reasoning. You're reasoning just as well, but in 2 dimensions, or you're diagramming in 2 dimensions, and so there's less compression going on. You're compressing less from this 4D world that we exist in. You're only compressing it down to 2 dimensions, so it gives you the same amount of abstraction, but with less filtering, so a lot of the things that we talk about in mathematics and logic, like for example the relation of associativity, that is like x times y times z, and then you go like this, and then the fact that it doesn't matter where you put the brackets, like if you can slide the brackets over here, doesn't matter. Well, that's obvious from the composition. The composition of the diagram makes it completely redundant to say this. This is completely it's given without even having to state it. Like if we only reasoned diagrammatically, we would never even have to think about this associativity rule. So this is that's just one example. David has his hand up there.
All right. Hello, Alex.
But hey, Martin,
Thanks.
thank you for the question. That was really good, really thoughtful, and thanks. Let's continue this conversation.
Yeah. Okay.
It's a great talk, Alexander. A really, really wonderful talk. It was really great to watch you think. It was really eye-opening. Yeah.
All right. Yeah. Thanks, Alex. It was great. I think we can nerd out like forever. I'm going to try to be kind of coherent with what you presented here and connect with what you just said about like, it doesn't matter where we put the brackets, at the end is the same thing, right? So my question would be about the doubles, the double ganger, the idea of being the same, like exactly what you said, like, it doesn't matter where you put the brackets.
If you consider going
That's
solo,
amazing, and somehow I can see, like, you know, the idea,
almost 100% of homeowners make the switch. For
the
zero
idea of
There's a few things you need to know in order to see.
there's some
There's some
radio
kind
in the
of,
background.
someone has his microphone on, we can hear. Yeah, okay.
So my question would be very simple, and somehow it's a really epic question. Is like when we do the equal sign, we say like it's equal. It is, you know, F, G, F, round G. It is deductive. So we make sense that actually it is the same path. You arrive at the same thing. It is equal. It is similar. It is the double ganger, right? It's the double. So somehow, like what you presented to us is to destruct this, right? I mean, is to say like there's no equality per se, or the modus ponens of logic, you know, going from one to the other. We can talk about logic. It's not that given, right? The path you take somehow, even with Girard, we know that it kind of matters, right? And so my point here is, I'm going to use huge words. What do you think about nominalism and the idea versus concepts, right? So there are entities that are just by themselves, and concepts wouldn't completely equal them, right? It would just be like, I don't know, difficult to write an equal sign, right? And so the idea of identity, that you had an amazing drawing when you had 3 lines, the loops coming back, right? Equals the identity, right?
Yeah.
So yeah, this, I just want you to express a little bit when you think about the idea of equalness and type, which type somehow encapsulate similarity, but in a very different way than the equal sign, right? I mean, like the idea of type. Can you maybe express what you think about that kind of type versus equal?
Yeah, I mean, I think that
there could be many things that end up in a type, but they're definitely not equal, but they do kind of, I don't know. And we know Leibniz's idea of the equal sign, which is just like, do you have the same properties as the other side?
Right.
Therefore,
Right, exactly.
Yeah.
Yeah, it's Leibniz's the indiscernibility of, what is it? Identity of indiscernibles.
Yes.
And indiscernibility of identicals. And that was thought to be the notion of identity, right? The idea that was identity. Identity is just that which, and that's what I go over this kind of whole idea in the article on something like an operational virtuality, because this was kind of what the Erlangen program, right? The group theoretical approach, which was saying like, oh, we can define an object by all of the ways in which we can operate on the object and still get the object, you know, all the things that we can do to the object where we still get the object. That is the definition of the object. So in proof theory, in sequent calculus, you kind of have this idea because you have all of the sequence, all of the different contenders of the propositions that are all equivalent, that give you the same, all of the same proofs. You have them aligned like that, and you kind of see them together. But yeah, and then category theory kind of gives us a kind of weaker notion of equality called equivalence, right? Where instead of, like in set theory, you had like, you have 2 sets and they're equal when you can pair them up, you know, 1 to 1. But in category theory, you have this notion of equivalence where it's kind of a weaker notion, but it still gets you off the ground. It's kind of like a pragmatic notion of equivalence where it's good up to a certain point. It'll work in a given application, it'll work in up to, they say, up to canonical isomorphism between categories, where you can define these kind of isomorphic relationship between different categories. But within that space, the two things are equivalent because they serve the same purpose, even though the objects, you know, inside, even if you don't know what the objects are, you can still reason about their equality or equivalence in terms of their relations to within the larger system. So it's like a top-down approach to equality that's called equivalence. You look down on the things and you abstract from the objects and you look only at the relations between them, and it gives you a kind of, turns out, a very, very rigorous way of thinking about what gets thrown around a lot is the idea that that's how mathematicians work, you know, in their daily practice. So it's called abuse of notation, right? They'll say in their daily practice, they'll say, oh, well, you know, this is not exactly the same thing, but let's just use it as that. And like, let's just say it is that, and then go, and then they start like working on the problem from a different angle, from a different mathematical perspective, using different constructions and all that. And then there's a gap there that in the traditional way was like, oh, well, you know, it's not exactly true, but let's just say, you know, it's an abuse of notation. But now category theory gives you a completely legitimate way of doing that. It's just, yeah, okay, in the category of that, in which, you know, you can map all of these morphisms and all these objects to each other, and it's completely legitimate. So the two cases are equivalent, and then you can keep on going like that. So it's very pragmatic. It's like a mathematical pragmatics. So in that sense, yeah, I don't know if that answers. It's a kind of a weakened way of thinking about equality.
Yeah, but I mean, at the end, like that's the whole nuance of like equal, going back to your doppelganger, going back to your difference between the materialist versus the idealistic. I think like, you know, I know math as well as, you know, as you, but like, I think that the way you framed it with the doppelganger and I think that's expressing that kind of idea of equal in the problem of equality in math and the idea of equivalence, etc. Like I think it quite resonated with that. So
yeah, it's this idea that that's why I kind of moved despair into this part of the talk, because it's no longer this kind of doppelganger, because he's not a doppelganger. He looks nothing like him, but he uses him as if he was a doppelganger. So this is a kind of notion of equivalence. You know, it's a kind of a, he thinks that he can use, you know, I don't know if you do it this way. He thinks you can use I should put it here. You know, these two are equivalent up to isomorphism, which is an isomorphism that only he has access to, or something. Like they're like, you know, they're obviously different, and yet he thinks that he's going to get away with this crime because he thinks that they're indistinguishable. Yeah. So this is the kind of thing that's happening, but hopefully more rigorously, and everyone can agree on it.
Great. Well, thank you, man. I can't be there next week, but I think next week is going to be super fun. Kind of like absurdity. That's my
pick. That's the fun part. Yeah.
Thanks.
Great.
Merci.
Thanks for your question.
Merci,
thanks for coming.
Merci.
Yes, Edward.
Hi, how's it going?
Hi.
So I might be coming at it sideways, but I guess I'm interested in so the title of the you know, this lecture is Kill Your Devils, right? And my mind immediately goes to the Zen concept of killing the Buddha, right? So if you meet the Buddha in the street, you kill the Buddha, right? And then moving that towards in the article, you sort of like trigger something with Scotus University, etc. Scotus being a Franciscan, Francis a, you know, contender for the second coming of Christ. So I guess like I'm seeing a relationship to like a messianism or a post-messianism, and seeking a way of sort of engaging accusations of messianism, like directed towards, you know, people attempting to develop, like, you know, post-human or inhuman analytic constructs. And I'm wondering, like, is there a bit of intentionality there, or do you have something to say about it? I guess also the detrivialization being brought into that as well, right?
Yeah. What this has to do with messianism, basically, right? Well, I don't know. I mean, I don't usually frame things that way. It seems to me that messianism is something like what we talked about with Turing, you know, this idea that you want to, you know, in his result on the, you know, the halting problem, you know, you want to get to the end of the computation. You want to get to the end without going through the computation. You kind of want to circumvent the causal structure, you know, the kind of historic the causal and historic things that need to happen in order for revelations to happen, and you kind of want to circumvent them and get directly to them. I think, you know, mysticism is something like that. It's something about mysticism that is kind of trying to find the secret code that allow you, like the oracle, that allow you to see which paths are the ones that complete, and which are like dead ends. So I don't know if that says anything about that, but univocity for Duns Scotus, I relate to virtuality. What he does actually is virtue, this idea of virtue, that virtues are, that he argues that when we talk about the virtues of God, we're also it's the same virtues that we're talking about when we're talking about the virtues of human beings. There's this whole disagreement, or like, I guess people were debating about this at some point, whether it's not the same kind of virtue. Like, oh no, God is, all his virtues are they're a different type, you know, they're
a different kind of stuff in a way. Yeah.
And he was saying, no, the virtues are the same. It's the same virtue. Like when we talk about virtues, and so he was building a bridge. And so that's very important, because then his notion of virtuality is very different from what then happens with Bergson, I would say, because Bergson, to me anyway, weaponizes the notion against modern science, rather than it being a way into talking about, you know, how those, like a way of approaching all those abstract mathematical or whatever quantized, spatialized, as Bergson would say, states and accounts of science, and kind of making them commute and compose with our lived existence. And that's, to me, problematic. I know Martin's a big fan of Bergson, but I can't hear your mic's off, Martin. I think he's
Okay, is that better?
yeah.
I think you're mischaracterizing Bergson, because if you remember, Bergson won the state prize in mathematics, and as a result, as a teenager, got to meet Poincaré. and they remained colleagues all the way through their co-tenure at the College de France. They contributed to collections together. And Poincaré was a fan of Kronecker.
Hmm.
And it seems to me that this distinction you're making between integers and the continuum really, in this context, go back to Kronecker's insistence of basically reducing mathematics to integers and the continuum. And then arguing, like Maimon did, that mathematics are a form of cognitive objects distinct from things and ideas, but necessarily emerge through the duration from the emergence of two out of one. And
Sure, but the question specifically about virtuality, I think I give examples, but I mean his relationship to Einstein and his whole kind of objection to the spatialization of time is I think just kind of, especially today, I mean, I think it's fine. It was fine to make that argument at the time. I mean, it's completely legitimate, but knowing what we know today, to be kind of going back to the, like, this is a kind of thing that was gained some traction, you know, with in the 60s and 70s with people like Prigogine and all that, like this idea that, you know, process, becoming and all that. But I think it's kind of misleading to always go there. And virtuality is actually much more of a, it's much more pragmatic and operational concept. And that it's much more useful that way.
Yeah, I don't know if I disagree with you there. All I'm saying is that, well, one, I read Bergson as a materialist, first of all, and there's lots of reasons why I make that argument, which I won't go into here. Second, he's very much interested in, as much interested in the continuum as Poincaré was. And if you remember, Poincaré, I believe, coming out of Kronecker, creates the major coalition which enables phase space to emerge, which is the operational form of the continuum, which becomes central to the physics and chemistry, as well as mathematics of the 20th century.
Sure,
but
and the three-body problem and kind of it's basically chaos theory,
right?
In a
Yeah,
nutshell.
and so there's one name that I wanted to mention, and I put it in the chat. Someone that seems to be following this, but also going explicitly back to
recursion.
Going back to intuitionist mathematics is Nicholas Gisson, and he's working within quantum mechanics and quantum field theory. And I'm wondering whether you've come across Nicholas Gisson's work, and he's someone that I've been attaching to because, you know, I've been really interested in the relational aspects of irreversibility, immanence, and emergence, and seeing them.
I'll look into it. I mean, I'm always open to. I just know that there's a lot of this quantum woo type stuff, you know, that where as soon as we talk about you know, quantum physics, I'll be like, oh, it means that consciousness exists or something, or like.
Well, yeah. Well, Nicholas is a functioning mathematical physicist. So I mean, he's not a dancing Wooly master, shall we say? Okay,
Okay.
that's
Good.
that's my only point, and I would love to hear from you once you
I'll-
check out, because I'm trying to make these decisions without anywhere near the background that you have. So I would appreciate your input very
yeah.
much. Yeah, thanks. I appreciate it.
And Edward, was that I don't know
Yeah,
if I answered your question, but
no, I'm trying to make something pop off, I think, and it,
yeah,
seems like
yeah,
it's
okay.
rolling. Yeah.
Yeah.
Well, thank you.
Good. Thank you. Anyone else? David Gauthier left, but he's left kind of a question about type and recursion in computer science, which is interesting, which has to do with the Y combinator in computer science. Yeah, I mean, it's all, I guess people are getting tired, but Antoine?
Yeah, I got a wild question maybe for the end. We're not. It's a yeah. When I'm a painter, I produce picture, and when you talk about composition, I really enjoyed the link between self-reformation of identity, and I was a bit astonished that we didn't talk about teleology, because as you talk through that each arrow needs to land somewhere, I thought about a more mechanistic teleological production of identity, as such as in posthumanism. If we throw so much arrows, aren't we exactly widening the spectrum of the future? But as such, what is the cybernetic principle of guidance within these range of getting there or not? And I thought it was something that was available in these kind of compositional models that you laid out. Maybe just to make a conclusion and produce a real question. If the arts can produce the identities that we hung onto and that we model ourselves within, what is a purposeful spectrum that we could aim at, knowing this hypothesis?
Yeah, within art. I think, I don't know, that, I mean, this question also, I think, relates to how AI is displacing artists, and kind of replacing a lot of creative work, and how artists are using the AI to kind of almost quickly iterate through the different aesthetics that are possible. They kind of like just trying to kind of come up with new ways of mixing them together in order to create new. And I was recently thinking about this question of what if these aesthetics, just like we talked about with linear logic, what if these aesthetics are also a limited resource? Because we tend.
We don't.
About now, can you hear me? Yes? Is it good? Because now I changed microphones. I don't know why my sound card seems to have.
Yes, it's good.
Okay. Where was I? Oh yeah. But what if, like linear logic, what if aesthetics is also a limited resource? And we can only, and like now with AI, we have this ability to kind of quickly iterate through all the possibilities. If that's the case, we might end up like going through all the possibilities really quickly, and kind of ending up like using them all up. And then what happens after? what do we do when there's no more, there are no more, because we think, or we seem to intuit that the mind is so deep, the human mind is so creative and deep that we can just keep on creating forever. Well, there's no end to it. We can just keep on going in this expanse forever, creating more and more things, beautiful objects of art and meaningful and whatnot. But what if we reach, at some point, there's diminishing returns and we kind of start getting closer to this limit? I think it's an interesting prospect to try to map the idea of linear logic onto aesthetics and art in that way. I haven't done it, but I think it's an interesting idea to explore. So I don't know if that speaks a little bit to the question of teleology.
Well, I think it's obviously a field that stimulates the imagination a lot, and I refer all the time to the hyper prefix, because then you break yourself on the imaginative horizon. But then it seems that I always want to level up or just get out of the paradigm in itself, but never to rebuild another paradigm. And so what is this kind of mental exercise to think without thinking? I feel it gets very quick to the noumenal kind of question of beyond the intuition. But is it a direction, or is it just pure confusion and then you're contemplating your incapacities? It's at the same time very stimulating, but at the other time it's just like it paralyzes. So I don't know how the arts can actually mobilize a stage to reflect on this horizon.
Mm-hmm.
Thank you very much. It's very interesting.
Yeah, I'm reminded of this idea that it's stifling. That what's the point of creating when it seems that all the images are gonna, they already exist latent in this AI. We can just draw them out. They're already there in a way. We can just draw them out. And so what's the point of creating anything? Obviously, we're not there yet, but that's the kind of where we're going and kind of where we feel we're going. And
if you remember, there's Giotto in the painting that invented perspective while producing pictures, and I still believe that producing picture is a trans-dimensional activity. We are 3D, we produce a picture, it's 2D, and within this shift, we do something very epistemological. And so I believe this kind of reiteration of picture, it's still not new. It's still not something that is above the novelness. Is something that it's horizontal, and this verticality might be the real paradigm shift. We are looking through identity as we try to expand or augment somehow something.
Yeah, I think something like that is true. I'm reminded of Deleuze and his idea of artists. Philosophers shouldn't tell artists what to do, or something like that. Or also when he talks about early philosophy being directed against the middle class, this idea that when there's a middle class of thinkers that arise, the sophists, for example, that they're free to think and create and have opinions about things. And early philosophy is just about shutting them up, this idea in Deleuze is very interesting. It's kind of different from most of his other work, but it's in What is Grounding? That was published by New Center. It's where he talks about the earth, or Socrates, basically his strategy is just to it's stifling, it just shuts up these opinions of the sophists, which is a kind of inverted way of looking at philosophy, of this kind of grand kind of gesture of figuring things out. But he's saying, no, it's philosophy was just there to kind of shut up this middle class that all of a sudden had new kind of creative tendencies and all that. And I think that's interesting to keep in mind. Don't tell the artist what to do, but the problem is now that the artist might feel stifled just from existing in this environment that seems to make creativity obsolete in a way. Oh, Aaron has his hand up. Sorry.
Hello. Yes, it's been a really interesting talk, and yeah, a lot of sprawling ideas everywhere. Initially, yeah, I kind of wanted to ask about aspects of. I think you kind of addressed aspects of equivalence and stuff, thinking about fundamental particles in physics that are identical, but right, they don't have a need to want to annihilate or destroy each other unless they're like antiparticles. I think this was a really good question that Antoine followed up with, to think about art and stuff. And yeah, I mean, personally, I am a scientist turned artist, and I work with Cosmos here, thinking about things about how aspects of juxtaposition and reaching new configurations can bring about novelty and newness. And yeah, it's a thing to think about when you say like, well, what happens when we, push the algorithms to just like, reach all the configurations? Is there a point to creating anymore? And I think the distinction there is that that would be sort of a demonstration of like a scientific process. And this could, be sort of a distinction of like what are the capabilities of technology, as opposed to an artistic way of thinking in how we enact these things with a sort of purpose in mind, when we have trying to act out into the world to actually bring forth a message, which is a clear distinction from simply being a demonstration of technological prowess. So I think that there is still a distinction for like why we have creativity, why it matters to think about these things. Furthermore, in terms of saying like, do these things like already exist in the latent space or something? Yeah, that's another interesting philosophical point to bring up. I think they perhaps exist in potentiality, but the act of actually enacting it in a unique process in a way sort of makes it an actualization. When I played with the Big GAN system, I was incorporating some chaotic motion, and yeah, you figure out how to do these things, you make things not work, and then you actually find out you break the system, and you can actually bring about like distorted images. And so this brings about aspects of glitch, and how glitch brings about creativity, and how these things don't actually exist in latent space, but they actually exist when you break the system.
Yeah.
So there's like, yeah, many ways in which to think about creativity, which go apart from actualizations of functionality.
Yeah, that's a good point. That's a good point. That artists are, this whole, well, I guess that's kind of what we want to talk about next week, I think, where I want to take it anyway. Because this was all about this, this idea of early philosophy expressing these evolutionary prohibitions, and it kind of, and then them becoming this kind of rule. But there's also this idea of this other philosophical dictum, ex falso quod libet, from false premises anything follows. And it's the idea that basically that you can get that by breaking the system you do get new things. It's almost like absurdity being this source of creative potential, and the two kind of the two notions, both of them are important to the kind of computability of like modern systems and functional programming and stuff. It's the whole idea of like we talked about in type theory, they put, you know, absurdity, like the bottom type kind of encapsulates all of the paradox, but it's also the initial object of the system. Everything comes out of that, you know. It's like an assertion. An assertion is just, I don't know if you guys can still see my, you know, I had this turnstile symbol. This symbol means absurd. This symbol is turnstile. It kind of means it's not an implication, but it's more like whatever's on this side, the turnstile gets it to you, and on this side you have the terminal object, which is truth. So you have this arrow going from absurdity to the terminal object or truth, and it kind of, you get it by rotating this turnstile. And that's kind of from false premises, anything follows. Basically, there are many arrows. This one. So you have this turnstile symbols here. This is the symbol for absurdity. And this is a symbol for terminal object or truth. And from the absurd, you get infinite arrows going out, you know. What I was talking about today was about how a certain interpretation of things makes us collapse everything into this one arrow that goes straight to truth. You know, nothing can stay here for very long. It immediately goes to something. And anything is true, like anything that is. So, oh yeah, and then what I wanted to say is that this, if you just leave this out, if you just say, okay, let me just, if you just say this and then whatever, this and then something like, if you start an expression with this turnstile, it just means like an assertion or a judgment. You're just putting it out there. You're just stating it. And art often has this form, you know, it kind of just is the assertion in a way. And you can imagine that behind here, there's always this kind of empty, kind of ghostly operator at work, which is absurdity. Kind of jumps out, the creativity kind of jumps out from this bottom type. But now I'm being very speculative here, but this is the kind of intuition I'm working with. But yeah, thanks. I mean, Aaron, that's, yeah, I agree.
Oh, thanks for sharing that.